Good evening, my audience. My name is Dr. Edward Wasrom, the tutor in Edwards Academy. This evening, we are going to commence a new series on dummy variable regression. A dummy variable regression is a kind of regression analysis that is done using qualitative information. And the study objective in this evening's class will be to look at the basic intuition behind conceiving the dummy variable regression and how to specify a basic dummy variable model. In my next video, I'm going to estimate a simple dummy variable regression output and also profile interpretation to such a result. Introduction. In previous explanation and econometric analysis, we have always assumed a situation in which qualitative variables are used to estimate economic relationship in the form of values or ratios such as investment, consumption, exchange rate, etc., which form the basis of econometric modeling. But the impact of qualitative series or variables or information need more attention in econometrics. And to ascertain how qualitative information like weather condition, the intelligence quotient of an individual, the behavior of an individual, educational level, and emotions can be used, a macroeconomic econometric modeling requires strong elucidation. And there are many qualitative variables that plays prominent role in macroeconomic econometric modeling, but they are different enough to give numerical values. For instance, the gender of an individual may play an important role in determining their salaries in workplace. Another example is that ethnic group influence may affect the consumption pattern of an individual. Also, the educational level of an individual can affect one's earning. And in view of the above conditions or examples so presented, it is imperative that we identify a means to give value to this qualitative information to enable us to have meaningful interpretation of its influence in real life settings. And this is the foundation of the dummy variable modeling. A dummy variable is used in econometric analysis to assign values to qualitative variables so as to enable us to make meaningful interpretation or inferential decision in real life. Dummy variables are also known as dichotomous variables. This can only be possible by arbitrarily assigning values of 0 or 1 to the two possible outcomes of the qualitative information. The researcher uses his own or her own intuition to assign values to the two possible outcomes of a dummy variable. And assigning such a outcome to the dummy variable is basically the responsibility of the researcher. Assuming, for example, we consider investigating the effect of income on consumption expenditure in Nigeria, and the researcher decides to look at the period before structural adjustment program and the period after structural adjustment program. The dummy variable will be represented or proceed with the acronym D1. And this D1 will be subdivided into two components. We have D1 equal to 0, D1 equal to 1. And D1 equal to 1 will be a scenario where we actually the period after the sub period, while D equal to 0 will be the period before the sub period, and before the sub period rather. And this implies that while forming the dummy variable data, the researcher will give 0 values to years before the sub period and give 1 to all the years after the sub period. And when the data is being formed in the worksheet, then the researcher will now use it to compute or to estimate whatever form of analysis he or she desires to do. So as we can see here, the equation of the above expression will be presented in our normal least square equation, but something different is noticed here. If you observe here, we have d1. d1 is the domain variable, and this d1 is dichotomous because it's split into two. We have d1 equal to 0 and d1 equal to 1. If we assume that d1 or d is equal to 0, that implies that wherever we see d, we will put 0. In our previous equation, we had d here. So if we assume that d is equal to 0, if you put d here, and anything multiplied by 0 is 0. So the whole of this will amount to 0. Then we will now be left with yt equal to this constant value plus beta 2 s2 plus the error term. This will remain our original equation. But if on the other hand we assume that the domain is equal to 1, then wherever we see d, we now input 1. And given that condition, we have gotten this. And since we have gotten this, we will now have alpha plus beta as our new constant. So basically, when d is equal to 0, our baseline model will remain the same. And when b is equal to 1, then our constant value, or the value of our domain, will now become alpha plus beta 3. So that is how the domain variable is being modeled. And when you actually succeeded in estimating an equation with domain variable, the interpretation is actually done in line with the constant value and the constant value of the period before SAP and the constant value of the period after SAP. So the interpretation of a domain variable model or output are not done like normal CITARES or OLX explanation or interpretation that we used to do. So the constant of the regression will change, and once the domain variable is included in the model, however, the output of the regression will not be affected. For instance, in comparing the consumption pattern of Nigeria before and after SAP, then which is this equation we have gotten, which is this equation, the slope will now become change in yt over change in xt, and which is equal to b2. So the b2 beta 2 will now become our slope parameter. Note that yt is equal to consumption and s2 is equal to income. Therefore, adding domain variable to this equation will amount to what we had previously. So basically, domain variable is used when you are dealing with qualitative information that cannot be measured, but the researcher will need to assign values to the information based on his or her intuitions. But assigning values to this information must follow rational thinking. Mainly if you are dealing with gender issues, researcher may decide to assign 1 to male and 0 to female. And while interpreting the domain variable results, the researcher should be careful enough to use the constant terms and the slope parameters to actually explain or interpret the meaning of whatever outcome or output that came out of the entire explanation. So this is what we know about domain variable. And in my next video, I'm going to do a very simple estimation, a very simple regression analysis using the domain variable as a baseline model, and also have them interpreted. Please stay tuned with my channel as I progress to estimate a domain variable regression and also have them interpreted. Thank you and God bless you.